Hi. So, hi, my name is Daniel. As Daniel said, I'm a software engineer at Etsy, and I want to talk a little bit about how we tackle deploys, how we keep them fast, and how we scale them out while we're scaling our team. And quick show of hands, who knows about Etsy? Sweet. In case you don't know, Etsy is a marketplace where people around the world connect to buy and sell unique goods. And just to give you like a rough ballpark number of where we're at, for August this year, we had 1.8 billion page views. We had over 5 million items sold. We had over $100 million of goods sold. The site has over 30 million members and over 1 million active shops. And you can see up there, those are kind of typical items you can buy off of Etsy. So handmade backpacks, earrings, notebooks, and of course, who doesn't love mustache stickers? So that's the kind of stuff you see when you go to Etsy.com. Talking about our technology stack, we're a very traditional LAMP stack. So we run on Linux, CentOS to be specific. We run Apache, Memcache, MySQL, and PHP. Behind the scenes, we also have different technology. We have Java for the search stack. We still have a Postgres database from which we're actively migrating off of onto MySQL shards, which are master replicated. And we also have some Python for infrastructure projects. We have Ruby for obviously for Chef for automation, our deployment tools written in Ruby, and a lot of the like smaller infrastructure projects. But the main site, the main Etsy.com, what you see when you browse there, is one monolithic PHP app, which we deploy as one app. So this includes Etsy.com, the page you see, and also our internal management application for our support team to manage support emails coming in and all of that. This all is deployed as one, and there are no branches. We use Git, but everybody contributes to the master branch all the time. There's no long living branching going out, because we believe in having continuous integration on the master branch and the use of feature flags. So what we call branching in code is actually just using feature flags inside of your code to have dark launches and flag features off until you're ready to release them. And we do deploy quite a lot. So as you can see here, the graph over the 2013, it started out around like 30, 40 deploys a day, and at the end we're able to scale it up a bit. And today I'm going to talk about how we tackle that and how we achieve to keep that fast. Those 40 deploys a day are from roughly 150 committers. So everybody of those 150 committers basically deploys every day. And how do we like maintain that? So one very important principle we have is on your first day you deploy. There's nothing more important you could do. There's no paperwork on your first day. There's no other thing. You sit down, you write code, and you deploy it to Etsy.com, and you get all the like scary feeling of just having deployed a huge site and everything's new. But you're excited, right? It's just starting a job. You want to change things. You want to improve everything. So this is your chance. Because from the first day you get to deploy, and usually your first project is just getting your picture taken in that phone booth right there, and then uploading it to the site. Because that's a very small change, because we also believe in very small changes deployed frequently. And it's a very nice first change, because after that you actually see your picture up on the site. And that's awesome. So how does that work? When you start, you log on to IRC. The whole company is an IRC. We have channels for the operations team, we have channels for infrastructure, the core platform teams. There are channels about Git, channels about cats, channels about our lunch and learns, and just get acquainted to like talking to people. You paste your favorite cat gif into the channel, and just talk to people, find out what you have to do and how the stack works. For code management, we use GitHub Enterprise, which has the big advantage that nowadays everybody has kind of already used github.com. So it's a familiar interface. You already know how to like browse code. You know how Git works. And even if not, it's a very familiar and very friendly interface to get used to coding, get used to how Git works. And also, every developer, when they start, they get their own VM. And this is a KVM-based CentOS VM, which has the full Etsy.com stack chef onto it. It runs the same chef cookbooks as the production stack. So when you, of course, in a like slimmed down version, you don't get 70 web servers for your VM. But in the slimmed down version, everything that runs and powers Etsy.com runs on your VM. And we also have one shared repository, it's called DevTools, where everybody can just commit scripts to, and it gets synced to all the VMs. So if you have just discovered a new way of accessing error logs, the database, or what gives, you can just commit it to the repo. And this very much helps us to have this communal spirit of, I just wrote the script and it helps me so much, I commit it to the repo, just pull and you'll have it too. And there's also a really nice interface for creating new VMs. So if you need to test something, if you're working on the search team for 2 weeks, which needs bigger VMs or something like that, you can just go to our internal webpage and create a VM for you. The general normal VM has 5 gigs of RAM, 1 CPU, and 40 gigs of disk. So if you if you write some code for the search stack and you need a bigger VM, like say with 10 gigs of RAM, you go to the site, you say what your VM should be called, you choose the size Cartman because that's our bigger VM, and you just click the mark for search and hit the button and you get a ready to go search VM. This really helps keeping development and production close to each other. It really helps for making sure what you write in development is actually also how it's going to run in production. So you've been writing code in VM, you're kind of happy you wrote maybe your first PHP, maybe you already know it, and you want to know, even though it's just an HTML link and you're first getting a picture up the page, you want to know if you broke something, if that looks right, if that is how the Etsy code should look like. Because really from the very first day, you have access to the Etsy web repo. From your very first day, there's nobody who you have to ask to get the commit bit for the Etsy web repo. So when you're done writing a code, you can invoke an internal tool we have, which is just called review, which is a very thin wrapper around GitHub pull requests, to send a review to probably the engineer that shows you around on your first day, or if you've worked there longer, to your peer group of developers who work with you on a project. And it will just open a pull request on the repo and automatically assign it to the person you told it to. So this gives us a very simple way of kicking off reviews, even if you don't know Git, because the local changes you did will be created in a temporary branch and pushed up to GitHub, and then the local branch will be deleted. So from your development perspective, it can just look like nothing really happened locally. So it's a very easy way, even if you don't feel super familiar with Git, to kick off a review, kick off a pull request, and get instant feedback on your code. And since it automatically assigns the pull requests to the person you told it to, it also is a nice way to see your GitHub notifications if someone assigned a pull request to you, if you're supposed to review code. And as you can see in the picture, we also use that for chef reviews, for example. So we don't only have operations engineers working on our chef cookbooks, but also software engineers. So if you change something because you think the Gearman cluster should be set up differently, you can just write chef code and send a review to an ops person, for example, and they will use the same workflow to tell you what to do differently and what you can do better when you're just starting out with chef, for example. So reviews are all awesome, but you also want to know if you broke the build, right? And you want to try out your changes and see if it breaks something. And as you maybe know, a very famous and popular person once said, do or do not, there is no try. But as it turns out, we actually have a try server where you can just push the diff you just wrote up to our Jenkins cluster and run your changes on the Jenkins cluster. For that, we also have a command line utility called try, which just takes that diff literally in HTTP posted to Jenkins. And that way, you don't have to run like IO-intensive tests on your VM, which is maybe not that fast, but you get the full capacity of our CI cluster at your hands. So whenever you feel like this should run full test suite, there's still a way to run single tests or smaller suites on your VM. But if you want to run the full suite, there is an excellent way for you to find out if you broke anything in the edge test suite. So how does try work? Well, behind the scenes, we have something called the bobs because they build our tests. And they're just basically LXC containers attached to Jenkins. We used to have a system maybe 2 years ago where we had just 5 big boxes which ran a number of Jenkins slaves, which was kind of awesome because they were named after transformers, so you could like, run your tests on Bumblebee and get that nice feeling of, hey, that's kind of cool. But the problem was that it turns out Jenkins executors are really good when you run one per box, but they're not really good when you run multiple per single box. So they would trip over each other. It wasn't fast. And we also had the problem that for IO-intensive tests, it would totally pack the disk. And jobs would influence each other, and it just wasn't optimal. So we switched to an LXC-based system where we still have our big boxes. And we put, I think we have 4 SSDs in there. And just split bobs onto SSDs. So we run 14 bobs on one build test, and only ever one IO-intensive job, which is labeled in Jenkins, can actually run on a disk. So this way we make sure that no 2 jobs which are IO-intensive run on the same disk and take each other down. And yeah, so all in all, our CI and try cluster has around 260 bobs. Most of them are actually attached to a try cluster. So we use way more bobs to actually test developers' changes than we do for the CI builds we trigger on deploys. And we constantly also monitor slow tests. So we have graphs and alerts on tests that are slow to figure out when someone changes a test and suddenly the characteristics of how the test is run changes and it slows down the build. Because we have SLAs around builds, so we don't ever want to build the QA test suite, for example, when it's longer than 5 minutes. So when it takes longer than 5 minutes, we take a look at the test, see why and how we can speed it up, because we want to keep it fast and we want to enable developers to deploy as often as they need to. Okay, so now you tested all your changes and you're going to try, you got the code review, it all looks good, your picture looks awesome on the page, you checked it on your VM, so it's time to deploy, which at Etsy means it's time to join the push train. This is literally what we call it when we deploy. It's the train of people which have changes which need to go out now. And this is all coordinated on RC. We have a channel called push, where you just, usually you're in that channel like every day, but you're supposed to join when you want to deploy. And the schedule of who gets to deploy and whose changes go out is organized in the topic. So that means the topic is the ultimate the canonical push train schedule. And our push queue is open from 7 a.m. to 10 p.m. New York City time, which just means that is the time where most of the operations engineers are around. We have operations engineers in the UK, but most of them are in the US, so it makes more sense to not have people push code while there are not a lot of people around, because between 7 a.m., 10 p.m., you can literally push as often as you want. So there's no need to accidentally wake someone up at night because you felt like you had to get that out now. And it's just the safer way and a nicer way to deploy. And the push topic looks a little bit like that. So in that case, Kyle and James are actually already at the production stage. The first name in the push train is the so-called driver, which pushes the button to deploy. And everybody else then has just changes in there. And then just, the pipe, is the next push train. As you can see in there, we also have config changes in the same train. So usually it looks a little bit more like this. And as you can probably see, hand editing the IRC topic in that case can be really problematic because you get all those nasty race conditions where two people try to join and then they override each other's topic, and then you have to remember what it actually was. You have to use the scroll back. So that's why we have an IRC bot called pushbot. And when you go into the channel and just run .join, it automatically adds you to the topic. So in 99.9% of all cases, no one hand edits the topic. We all do that through pushbot. And it has commands to let you tell the group, your push train, that your changes are in. So as soon as you run git push, you run .in to tell everybody that your changes are in. When you've tested on staging and production, you run .good, which adds a little asterisk to your name. So everybody knows that you have tested your changes. And when the push plan is done, you just write done, and the next one's up. So in the IRC front end, it looks a little bit like this. So pushbot also lets you know stuff like you're on production right now, so this is the link to all the important graphs you should be watching right now. Or when you're outside of push hours, like you try to join the push train after 10 p.m., pushbot tells you that it's after push hours, and there's a link to an internal wiki page because it's not impossible to deploy after 10 p.m. because there are emergencies where you have to flag stuff off, where you have to deploy a patch. But you have to be aware of what it entails to deploy after 10 p.m. So it links you to the wiki page to just let you know. So how does it actually look for the driver of the push train? How do we actually deploy code? And for that we like to call it a one-button deploy, but it's actually a two-button deploy because we have staging and then production. And this is the web front end. It's the Sinatra app of how we deploy code. So once everybody has pushed and run the .in command in IRC, you hit the first button, which is labeled Save Sequences with tests, because everybody loves and writes tests. And that is also the moment where we kick off our CI build. So at that moment, it deploys the app to staging, builds the asset, before that builds the templates, and also kicks off the CI build. For the driver, it looks a little bit like this. So behind the scenes, Deployinator, or deploy tool, is basically a huge set of distributed shell commands in rsync. And everything those commands output, you get to see in the run log. And the nice thing about that is that there's a really great tool in Unix to actually note errors, which is the standard error descriptor. And that will show in red on your deploy screen when something goes wrong. So whenever a command prints something standard out, you get the error in your web front end and can immediately check what's going on. Have you broken the build? Is it because some server is down? But it also gives you an easy way to show notifications. So for example, if you're the very first person to push in the morning and someone git pushed the night before but forgot to deploy it, you actually see if there are stale commits, which are by our definition commits that were pushed 6 hours or longer ago. And it will let you know that there are changes in your push you might not expect, so you know what to expect in your push. And it also checks if all the web servers are actually available and you can get the currently deployed version from them, because in your buttons it shows you a link to the diff that goes out, and if you can't determine the version that's actually on the web, that's kind of bad. So when that happens, it grays out the buttons and tells you, well, I do not really know which version runs in production, so are you serious about pushing now? Is there a problem going on? And you can click to override that. And Deployinator will let you know, okay, you've chosen to override the version check. That means Jenkins diff URLs might be wrong, GitHub diff URLs might be wrong, and more stuff might be broken where we rely on versions, but you've chosen to, that deploy to be an emergency deploy. So continue. And there's also a way to lock down all pushes. So if there's something wrong with the Git push, and you just notice that the code you pushed is not fine, and you don't want it to get up to get deployed, you just hit that button and the web pushes are all locked down, and only you can clear the lock. If you say, okay, you can release the hold, everything's fine now, clear the lock, push again. And also the whole system is on GitHub. So if you're interested in setting up a deploy like this, you can go to the URL and check out Deployinator. As I said, it's a simple Sinatra app. It mostly runs shell scripts in the background. Yeah, so check it out. We also had a couple of downsides to how we manage deploys. One of them was definitely that deploys were atomic. We did rsyncs of all the code to the webs, to our web service, and then did a local rsync to actually rsync it over into the document root, which meant at any given point during a deploy, you could simultaneously run a new and old code in the same document root. So this means there's this, like, even though our deploys usually take about a minute, there's this 1 minute of time where you could actually be in that limbo state. And so a common strategy was to just split up your changes into 3 deploys, which was the first deploy to add the new functionality, the second deploy to remove the call side of the old code, and then the third deploy to actually remove the old code. Because if you didn't do that, you would see exceptions and missing data and generally dragons. So that was kind of like a bad state. That is why we decided to implement atomic deploys. And how we did that is, from the basic principle, kind of easy. So we have 2 document roots, which we call yin and yang. And the active in document root that is configured in Apache was just a symlink to either one of those. So whenever we deploy, we just rsync to the standby document root. And once that is completely done, we atomically switch the symlink over to the new document root. This is a really simple and nice way of actually doing atomic deploys. However, there are some problems which you have to know about if you want to do atomic deploys like that. So the biggest is basically when you do symlink swapping in between requests, you could get the same problem when you have code that actually includes other code, which you probably have because it's not a single file via web application. You could start a request on one document root and finish up on another one, and it will have the same problems as I described before because you have 2 different versions of code. So that's why we wrote a small Apache module, which just does a real path on the symlink and stores that as its internal document root. So it's implemented as a post-read request hook, which means after Apache has actually read the request from the client, it runs the real path on the symlink and stores that as its internal document root. And from that point on, the whole request only knows this document root, which is in our case var .html yin or yang. And this is the true document root. And we also implemented caching in there because if you get a lot of requests and you probably don't deploy faster than you get requests, there's no need of actually checking if you're still in the same document root for every request. So our setting is to cache it for 2 seconds, but it's configurable as long as you want, basically. If you have that in place, you can do atomic deploys with each simple web app, basically. So assets are going to be in there, simple PHP pages are going to be in there, and all you have to do on the PHP side of things is if you have a single front controller, just set the include path based on the document root Apache gives you, and you're done. You have atomic deploys. Unfortunately, at Etsy we don't have a single front controller. We use HTX's routing a lot. We have different entry points into the code base, so we couldn't set the include path at this single front controller. That's why we wrote a PHP module, which is kind of analogously to how the Apache module works. And it just either asks Apache for the document root, or if you run CLI apps, for example, with PHP, it does the real path itself and stores that as the known server root. And then based on the pattern you give it, which is your configured include path in your configuration, it just replaces the pattern with the current document root. So that means we can now remove functions and their call site in the same deploy. We don't have to do any restarts because our opcode cache will just pick up the new files. We're using opcache for that, the Zend optimizer opcode cache. And because it's real path based, it's gonna cache all the files that haven't changed in between two deploys. So once you do your second deploy and you're back on your original document, you can still use all the entries in the cache that haven't changed since 2 deploys ago, which means there's no heavy cache clearing. You don't have a lot of problems with cache warming, which you would have if you restart Apache, for example. But there are also a couple of things to watch out for. So your code has to be written to respect the include path. There can't be any fully qualified path name inclusion in your code, because then you will not get the code your current environment is running on, basically. Another big thing is that atomic symlink swapping can only be done if you actually create a temporary symlink and mv-t that symlink. Because if you do like the regular way of running ln-sfn or whatever it is, it actually, if you strace it, it shows you that it's not atomic. It's creating a temporary link and then swaps that back in. So you have to use that to actually get atomic deploys. You want to know your system to figure out what setting you want to set for the caching of the actual real path. And you have to know that if you run a redo with 2 versions, like always swap between 2 versions of the document root, you have to have enough space in your op cache to actually store 2 versions of your application. And the atomicity of that system is only during a request. So while you're deploying to your whole cluster and you have AJAX calls in there, it's possible to have the page render run on the first document root, let's say in, and then it creates an AJAX request, which then goes to another web server and runs on Yang, for example. So it's only atomic in the request, during the request. So this got us a lot of speed up because you didn't have to split up your deploys anymore into 3 different deploys. But still, we saw kind of a plateau of how often we could deploy per day and how often people were able to deploy. And that was basically because deploys took us about 15 minutes. And config deploys were a little bit faster, but still there's testing involved. You want to make sure you didn't break staging, you want to make sure you didn't break production. So with deploys taking about 15 minutes, and the normal working day, let's be honest, not a lot of people get up at 7 a.m. to deploy, and not everybody stays until 10 p.m. to deploy. So if we set like a normal workday where people maybe deploy from 10 a.m. to 6 p.m., we only get around like 30, maybe 35 or 40 deploys in before there's just not enough time to actually deploy. And this resulted in long waiting times. So people were like, man, now I have to wait 45 minutes to get my code out. That's horrible. What am I doing? Let's check Twitter. And we didn't want to end up in that situation, right? Where deploying is the new compiling, and people are like, why are you checking Twitter? Why are you doing a handstand and playing table tennis? And then the answer is just, oh, I'm waiting to be up in the push queue. So we didn't want to have that. Deploying should get out of your way. You should be able to deploy when your code is done, so you can get back to coding and do what's fun. So we basically just split up the queues. So we now have a push, still the push train, which is just for web code, and we created a new push channel, which is called config, which has the same setup with pushbot, it has the same rules, but it only pushes out our production PHP configuration file. So now what we see is that it didn't speed up a lot, the web deploys, but config deploys are now basically instant, and the queue is always clear because you're not bound to wait for the longer lasting web deploys to get your quick config change out. And that helped a lot with like speeding up deploys and making sure as soon as your code is done, you can actually deploy it. So that was mostly about our deployment system. So now your code is on production, right? You have deployed, you're fairly sure it works, but can you be really sure? And for that, we have an abundance of dashboards, which actually show all the deploys as vertical lines. So you actually know, like, if you see a spike in a dashboard, is that related to a deploy? Did that start earlier? Did that, like, is that an impact from an early deploy, from a chef deploy? All the changes in our chef cookbooks also get a deploy line in there. And most of the important metrics are on our so-called deploy dashboard. So we have error pages, logins, checkouts, for example. We have what we call 3-ounce weather reports, which is just Apache throwing 500, for example. The current CDN balance is on there, so we're using multiple CDNs, and so that you know which CDN is actually taking most of the traffic right now. And also DB metrics, so you know if you just deploy a query which is not really nice to the database and is now causing pain on the data backend. We also have what we call a super graph, which is basically a Node.js-based front-end to tail-f pipe graph. And just shows you all the error logs from all the webs, from the API, from our daemon workers, in like a screaming web front end. So after you deploy, you just go to Supergraph and check if there are any like exception throwing, if there are errors coming in, and stuff like that. And we also have an internal dashboard, which just shows you the status of all our internal tools. So whenever we have a problem with CI, we can flag the service CI as having a problem. We can do that from IRC, you can go to the web page and flag it. But that actually helps us a lot when there's a problem, so we don't have everybody coming into the CI channel asking, is there a problem with CI? Because you can see it on the status board. And the same goes for Graphite or Defiance. If there's something of Deployinator, Supergrad, and a lot of other services use daily to help us deploy. So to summarize a little bit, our current setup has scaled to around like 150 engineers deploying every day. And we're constantly trying to improve the speed of deployment, the ease of deployment, and to make it as seamless as possible in the day-to-day development workflow. That means for us finding weak parts in the deployment system, listening to developers what really pains them the most about deploying, and figuring out ways to make it more robust, make it faster. And also, we're constantly trying to bring development closer to production, because the only way to know that your changes are most likely not going to break production, and to be really sure about that is having development where you write your code be as close to production as possible. That's why we run the same Chef cookbooks on development and production, and have the same stack, Chef on your VM, that you're actually going to run your code on in production. And the last very important point is that not being able to deploy for us is a priority one bug. It has the same severity as the site being down, because we regard being able to deploy constantly as one of the biggest features we can have for developing the site. So when there's a problem with deployment, everybody who knows how to fix it drops what they're working on, because this is a priority one bug. If you want to know more about it, we have a blog at codescrafts.etsy.com. There are a lot of more talks that go deeper into specific topics, which I just only briefly talked about. at the URL. We have a GitHub page where most of our tools are open source, and we love pull requests. And if that sounds super awesome and you want to work for Ashley, we also are hiring. So, any questions? Yeah.
You mentioned.
Do we have mics, or should I just repeat the question?
You know, go ahead, repeat this.
Okay, you mentioned that you use GitHub, Git push and pull request. Pull request, right, for code review. Can you elaborate on how that process works?
Yeah, so the question is basically how our GitHub pull request workflow works. So, right at the start, I said we don't use branching, which was a little bit of a lie because we use those like very short-lived branches for pull requests, which are just when you run a review tool, it pushes up a temporary branch to GitHub, opens the pull request, assigns it to the person you told it to, and then it sends out an email to everybody included in that review. And then basically we have a lively discussion, as you can see on github.com as well, about like what to change, if that looks good. And we also have an internal grease monkey script, which is also open source, which gives you nice accept and reject buttons, where you can just like hit accept and it just like comments with this looks good, accept it. And after that, you commit your changes locally. So we don't usually use like a push button because you should only ever commit to origin master when you're up in the push train. So after you got like the okay on the review and know that your build passed, you commit it locally and push it up.
So you use the same repo and not, unlike GitHub.com, you don't clone the repo into your own version.
Oh yeah. So
in that sense, it's not the same kind of.
Well, it kind of is the same because pull requests per se don't have a notion of where you send the pull request from. You can easily send a pull request from a branch to another branch. But yeah, it's not the usual open source fork the repo and then send a pull request workflow, but it's all in the same workflow. Yeah.
I'm just curious about the size of your Jenkins cluster, how many jobs you have running?
Maybe Greg knows a little bit better about the specific numbers.
We have many. It's actually a general purpose tool, but maybe a better way to answer this would be how many actually run during deployments. Right now, the job that runs on the try server and the job that runs the first build that runs during deployment, QA build, has about 15 unique jobs in it. And then we have two separate test suites which run during deployment as well, and those each have about 5 jobs in them. At the moment, total on our production Jenkins server, we have around 100 unique jobs that run with varying frequency. Many of those are ad hoc jobs that get run only manually.
What's the most time-consuming part? What's the most time-consuming part of your deployment that you're not able to get
From the actual deployment?
Yeah.
Building templates and assets. This is like takes the most time because we have a lot of languages, so we have to build templates for a lot of languages. The assets, depending on how many changes are there in JavaScript and CSS, we have to compile more assets. But basically, rsynching the code over to even to the. So we have right now we have around 70 web servers and 24 API servers. So even getting the code, and 40 human workers. So even getting the code there is usually a matter of a minute, 2 if it's really slow. But actually waiting for the template compile takes a lot longer. And then, as I said before, we have an SLA of 5 minutes for the QA part of our CI build, which often takes around that time. So The usual deploy looks like you're first waiting for the template compilation, and then there are an additional like maybe 1 or 2 minutes where you wait for the QA job to finish. And then manual testing depends on your change, right? So there, a lot of times you have changes where you want to be really, really sure because you touch checkout, you touch login, stuff like that. So you can easily take 2 to 5 or longer minutes to test on staging, and then again on production to make sure you really didn't break checkout, for example.
And that review script that you're talking about, that's open source, right?
It's not yet, but we're working really hard on that to get it open source because it was really a quick script wrapped around our specific needs, and we're right now working on getting it into a state where we can actually open source it.
So, going back to the question that Sergey asked, you essentially, when you're doing a pull request, what you're doing is you're merging the pull request into the local copy of your GitHub repo and then pushing it up, right?
Yeah. So for the actual Git side of things, we try to mimic the SVN way of pushing because it's really a web application really lives in trunk or master, right? So there's no if you're doing branching code, you really want to have this linear master of what is your deployment timeline, how does your change timeline look like. So on your machine, we always push with rebase to actually put your commits at the top of the commit timeline to actually mimic that this is the newest change that is going to go out with the deploy. But we never use the merge button, and we usually don't have merge commits because it's all that very linear rebase timeline.
Does the eventual push, is it the guy who's requesting it, or is it the guy who's approving the pull request?
Requesting, approving what?
So like, let's say I have a pull request, right?
Right.
And there's like 6 or 7 people who are commenting on it. Is it one of those people who actually does the final push?
No, it's always the developer. If you change code, it's your responsibility to push it up to GitHub. It's your responsibility to test it, and it's your responsibility to get it deployed. There's no like throwing code over to the wall to someone else who then has to deploy the changes to make sense of what you wrote, basically. So the review process is just to get insights from other people who have also worked with the code. If there's something to improve, to get more eyes on the code, but it's up to you when to merge it and push it and deploy.
Actually, since you're doing a push, actually the pull request is doing it on local. You have to do it.
Yes.
Just to confirm, so you do not have to go through the review process?
Technically, no. There's nothing stopping you from just pushing and deploying, other than the graphs going up after that and people asking you what that your change.
Right.
So what's the consequence to the graphs going up? Like, so other than just ridicule from the, is it just a ridicule problem? Is it a peer pressure?
There's no
brainstorming?
ridicule problem. Like, you don't assume people that come to work to do a bad job, right?
Yeah,
It's just like,
of course.
there's a spike in the graph. Everybody who was in the last push train figures out which change was the problem. You either revert the change or go forward with a fix if it's fast, and then you check the graphs if the spikes go back down.
Can you tell me your strategies about managing database schema changes, dependencies between database schema changes and code changes?
Yeah, so schema changes they are continuously deployed, but they're not as frequently deployed. So we do schema changes about once a week. And schemas always have to be backwards compatible because we're not tying schema changes to deploys. So we have what we call a schema change Thursday. So at that point, it can be that your schema goes live, but it can also be earlier or later, depending on the schedule of the DBA or the developer who's doing the schema change. And yeah, so we have a couple of rules around how schema changes can look. So they have to be backwards compatible. You don't do deletes, so you don't accidentally like delete columns from data which is still used by code, and it's very not tied together.
Most schema changes are added columns there.
Yeah.
To the background.
Right. Yeah.
Do you ever do rollbacks?
No. There's no such thing as rollback. Because at that point, you have no idea what actually changed in your application. You don't know if there was data written to the database, which is now not backwards compatible. So we always ever roll forward.
So how many Git repositories do you have?
What's that?
How many Git repositories do you have? You have to separate it like a front end in one repository, back end, or like API, another one?
No, it's all one Git repo.
Just one?
Yeah, so we have this monolithic PHP application and it's all in one repo. Some exceptions are the search stack because it's completely different, and the photo stack, which is shelled out of that. But the API, the web, our internal tools, all one repo.
So with the prior about Jenkins running multiple jobs post-deploy to validate it, and it's only roll forward, so what happens when those jobs fail?
So it depends which job failed, right? So we have the QA and our princess tests running when you deploy to staging. So when those tests fail, you figure out why they fail. You push a change and you redeploy to staging. And basically the same goes for production. If the production test failed, you have a problem in production. So you look at the code and figure out why it's broken. Because we usually have very small change sets, right? So it should be kind of fast to detect which change actually broke the build. And then you either revert the change or you fix it and redeploy it. But it's all a matter of figuring out which change broke the build and redeploying.
So I have related to QA. So let's say you have QA tests going on after it's supposed like automatic. I assume you also have a QA people.
No, so we have a QA team, which is basically an infrastructure team to manage Jenkins and test infrastructure and test setup, but we don't actually have someone coming in and testing your changes to see if they work or not. As a developer, your responsibility is to test your changes and make sure that it works.
And what you said was like, if you want to fix something that failed, like you just deploy it, what if you're not part of the next push? Is there a way to like prioritize? Like this has to go now.
Oh, yeah. So in that chain of commands I just showed about pushbot, you only ever hit .done when you're confident that nothing broke. And even if you, like, say you're confident and everything looks good and you do .done and something actually breaks, you can still jump the queue, and there are commands to jump in front of someone. So when that happens and people are, the next train is deploying basically, you can either ask them to join the train, so there are commands to join the train, or if it's like really, really urgent, you can jump in front of the train and say, hey, I have an emergency push because this is broken.
Any other questions?
Do you have some IRC commands that actually, instead of you going to the UI, do the Jenkins trigger from there?
To do what? To trigger the build?
Yeah.
Yeah, the build is completely triggered from the deployment system. There's nothing you have to do. Like when you hit the deploy button, the deployment system tells Jenkins to run the builds, and the results will also be posted back into IRC with a link to the actual results page.
Sorry, what I meant was, can you do it from IRC rather than going to the UI and then clicking the button?
Deploy from IRC? Not yet.
Not yet.
It's something we want to do, but we haven't done yet. Was weird?
I don't know. When so as you have 150 developers all adding little incremental code changes, what is the expectation about for whatever change they put in, adding more QA tests or not, to the change? Like in other words, I would imagine if everyone keeps changing little bits of code and they keep writing little tests to prove it, the amount of QA tests has to keep growing unbounded. Or is there not an expectation that the amount of QA tests is ever increasing with the development code change? Do you know what I mean?
Yes and no. So, of course you have to test the changes and you have to write tests for stuff you add, but you can never catch everything in a unit test, right? Or you can never catch everything in test. You never know how people use the system. So, monitoring and watching graphs is the other side of testing. So you want to have this continuous feedback loop of actually taking a look at the graphs and see if everything's fine, and if not, figure out what it is. So there's nobody checks on you if you actually wrote a new unit test for something, but you have to make a conscious decision of does that make sense to add a huge test? Can I just add an existing test? And as I said, we monitor test runtimes very strictly. So whenever there's a slow test or a new slow test, we try to work with everybody to figure out how we can make it faster and how we can keep it fast, basically.
Sort of off topic, but do any of the teams use any planning strategies like Scrum that would have like a time box?
Yeah, so we have a lot of small teams for writing, basically adding features to the site, and there's no global policy of what you have to use. Basically, teams decide for themselves how they work best.
And so, but are there any time box ones where there'd be like a lot of work done at the end of the week or at the end of the cycle?
Not that I know of.
Kind of in connection with the previous question. After the sprint is over, you just flip the switch in the code, right?
To enable feature?
Yeah.
Yeah.
To kind of finish the feature service, feature circle or cycle.
Right.
But deployment is not related to that.
No. Well, flipping the switch is a config deploy, basically. But we never go from 0 to 100% users for something. So we have ramp ups in there. We usually go like 5, 10, 15% and stuff like that to figure out to run our experiments to see if the feature does what we want, if it has the effect on the users we want, and also to simply do load testing to see if spikes go up on the database when more users use the feature and stuff like that. And that is basically it. So when you're done writing code, you ramp up your feature and tightly watch graphs to see what's happening.
So your experiments, as you call them, are being tested on your customers. Is that am I getting that?
What is your strategy for flipping the flags? How's that? What mechanics behind that?
It's basically a big PHP config file which gets deployed with the config deploy. Is that what you're asking?
Yeah.
Yeah.
How you make that change on targeting servers to make the change?
No, it's basically the same. It has the same semantics of a regular deploy. You edit the file, the production config file, and you push it with the same tool but in a different queue. And then you watch graphs and make sure everything works.
If you enable a feature only for certain users, do you for all those users to different servers that they run different code, or?
No. All the servers are always running the same code, and all the bucketing and the experiments are done in the code. So there's no bucketing per server, basically.
So the switch is just a if statement?
Yeah, basically. Yeah. So you have stuff like if feature foo is turned on with this and not with this. Yeah.
Can you provide some more detail to your graphing? The part that does the graphi and stats.
How it's set up.
Like, how do you aggregate information from disparate systems before you actually show it to whoever?
Right, so all the system level metric stuff is Ganglia for us. And we have different clusters for the different concerns, basically. And all the application level metrics are going through SC and get then aggregated in like mean, standard deviation for timings, or regular aggregation for counters, and then send off to graphite. And then the dashboards I just showed with the deploy lines is basically a combination of either ganglia graphs if you care about system metrics. So the deploy dashboard, for example, has Apache requests and database metrics on there as well, which are coming from ganglia, as well as logins, checkouts, which are coming from SetsD graphite.
Do you also get stats from Akamai and stuff like that?
Yeah. Yeah, we also have CDN metrics in there. We have Logster also, Logster, which is one of our open source tools to get metrics out of log files. And but basically, everything that's system level is in Ganglia, and everything else goes to Graphite. Yeah. No questions. Awesome. Thanks for listening.